You join a new team. On your first day, you open the code base and see 500 files. Names are inconsistent. One file talks to 10 others. You need to change one payment rule, but you are scared to touch anything because a small change may break something far away. Where do you start? That feeling is not because you are a bad developer. It usually means the code was written before anyone decided how its pieces should fit together. That design step has a name: low level design, or LLD. Break the name down: low level design. Design means we are planning before building. Low level means we zoom one level down from the whole system into one part of it. LLD is simply the blueprint of one component drawn before the code. By the end of this lesson, you will know exactly what LLD means, and you will walk away with three simple questions that can turn any messy requirement into a clean class design. Imagine building a house. Before anyone starts work, an architect creates the big picture plan: 3 bedrooms, 2 floors, and a garage. That plan tells us what major parts exist and how they are arranged. In software, that is high level design, or HLD. HLD answers questions such as: which services do we need? Which database do we use? How does a client reach our system? Here is what a real HLD looks like. A user opens your app. The request hits a load balancer. Behind it, 4 servers share the work. They talk to one database which copies itself to 2 replicas. Boxes and arrows, that is HLD, not one line of code yet, but an electrician cannot wire a house from that big picture alone. They need details: which wire runs to which room, which switch controls, which light, and where the electrical panel is. That is the role of low level design. LLD decides how one part is built internally: the classes, the data they remember, the actions they perform, and the relationships between them. So remember this: HLD is the city map, LLD is the room by room plan. We need both. They answer different questions. LLD becomes much less scary when you ask three simple questions. First, what are the things in this system? In code, we usually model a thing with a class. A class is a blueprint for one kind of object. In a food app, an order, restaurant, and delivery partner can each be classes. Second, what can each thing do? Those actions are called methods. For example, a restaurant can confirm an order and a delivery partner can deliver it. Third, what information does each thing remember? And how do the things connect? Stored information is a field. A connection is a relationship. An order can keep a reference to one restaurant and one delivery partner. Things, actions, connections. If you can answer those three questions, you have started doing LLD. Quick check. Suppose I say our app needs a database and a cache. Is that HLD or LLD? Pause for a moment. That is HLD because we are choosing major system components. LLD would sound like this. We have a cache service class with a get method and a put method. Notice how we moved from a system box to the code inside that box. Before we look at any code, let's understand how messy code is born. Imagine we build a tiny food app and we never stop to plan the design. Everything goes into one class. That single class has to find the restaurant, take the payment, and arrange the delivery, all by itself. When one class knows too much and does too much, developers give it a nickname: a God class. And here is why that is dangerous. The day you add a new payment option, like Google Pay, you must reopen that same giant method, the one that also handles restaurants and delivery. A small payment change now lives right next to unrelated code, so it is easy to break something by accident. Keep 3 words in your head: restaurant, payment, delivery. 3 different reasons for one class to change. Now let's look at the actual code. Here's the class. We call it food app. Inside it sits one big method, handle order. It receives everything at once: the food, the customer, the restaurant, the driver, and the payment method. Now, watch what this one method does. First, it finds the restaurant, then it takes the payment, then it assigns the delivery. Three separate jobs packed into a single method. And when we add Google Pay, the new payment code goes right here in the middle of the restaurant and delivery logic. Restaurant, payment, delivery, three reasons to change, all trapped in one class. That is a God class on one screen. Now, let's redesign it with our three questions. And this time, no code yet, just thinking. First, what are the things? Restaurant, payment, delivery partner, and order. Second, what can each one do? Restaurant confirms the food, payment charges the customer, delivery partner delivers the order. Third, how do they connect? Order sits in the middle and coordinates them. It does not need to know payment details or delivery details. It simply asks each object to do its own job. Now, every class has one focused responsibility. So if a payment rule changes, we only touch payment. If delivery changes, we only touch delivery partner. Order stays stable because it delegates instead of doing everything itself. That is the real payoff of LLD. Easier changes, clearer ownership, and less fear when you edit the code. With that picture clear, let's write it in code. We'll start with the three workers: restaurant with a single confirm order method, payment with a pay method, delivery partner with a deliver method. Each class is short and each does exactly one thing. Now the order class. It holds a reference to a restaurant, a payment, and a driver. And its place method just calls them in sequence. The restaurant confirms the order, payment charges the customer, and the driver delivers. Look at how order reads. It coordinates the workflow, but it never contains the details. That is the same food app, redesigned so every change has an obvious home. One more reason this matters: studies of real teams show developers spend almost 88% of their time reading and maintaining existing code and barely 12% writing new code. So the real question is never, does it work today? The real question is, can the next person understand it, reuse it, extend it, and maintain it? Understandable, reusable, extensible, maintainable. Good LLD is how your code earns those four words. Your turn. Think about Instagram. We have a user, a post, and a comment. Which class owns which? Can a comment exist without its post? If a post is deleted, what should happen to its comments? Take 10 seconds and decide before I show you one possible answer. One sensible design is a user has many posts and a post has many comments. In this model, deleting a post also removes its comments. That is relationship thinking. Not only naming the objects, but deciding how their lifetimes connect. Let's finish with three ideas. First, LLD decides the classes, their data and methods, and their relationships before we write a large amount of code. Second, HLD gives the system level picture. LLD explains how the parts are built internally. Third, whenever you begin a design, ask, what are the things? What can they do? How do they connect? And here is the road ahead. LLD1, design principles, the rules of good structure. LLD2, design patterns, ready-made solutions the industry trusts. LLD3, machine coding, full interview problems end to end. Next, we will make the HLD versus LLD boundary even sharper. When should you stop drawing system boxes and start designing classes?